section over Ohm's law. Ohm's law is broken up into two major, we call them the big two formulas. I hate using the word formula because it always distracts some people that don't like math very well, but it's easy. This is multiplication and division, and it's actually set up in a really handy way, but you do have to memorize it. Okay, it requires you to memorize it. The first and the most important Ohm's law formula says that the voltage is equal to the amperage times the resistance. And I've just wrote this out here for you, and the goal is for you to memorize E over I times R. E over I times R. E over I times R. That's Ohm's law. Okay, so memorize that. Be able to write this down at any time. You will have to utilize both of these doing Ohm's law. So E is equal to I times R. And now look, I over here, I is equal to E divided by R. If you want to know R, R is equal to voltage divided by amperage. We've already been through redneck theory, and we know that E is voltage, I is current, amperage, check with a clamp on amp clamp, and resistance is ohms. You're ohming out your board every single time before you plug it in to make sure that you have sufficient resistance. The second formula is the pi formula. It's to give us power. P stands for power. That's work. Work is watts for electricity. So what does P represent? Watts. When you go to the grocery store and you need to buy some light bulbs, you buy light bulbs based upon watts. And you could take 120 volts and multiply it times its current that it's using, and it gives you the watts. Also, if you know the watts and you know the voltage, you can take watts divided by the voltage, and you can get what current that it would be pulling. And this is actually it's a very common formula that we have to use as service technician, because it tells us a lot of times what wire size that we need to use. Okay, both of these will be used when analyzing electrical circuits. All right, so we'll be going back and forth from this to these rules. Now I wrote it over here on the board on the left. It's also in the lab, wrote up there, so you have resources to write these down in your book. Another thing that you have to memorize. Now, some of this you already have memorized and you don't even know it. Okay? And you have it memorized because you've been in lab, and you know that if you take a series circuit and you start out with 120 volts and you put 3 bulbs in series, that the voltage will drop through each bulb, right? And then you can add those individual bulb voltages up, and it's going to equal the total voltage. So we'll look at the rules of series here first, and then we're going to look at the rules of parallel. And I've got it in opposite sides because we're going to work some problems here in the middle, and we're going to have to analyze, okay, is it a series or parallel? And once we recognize that, and it may be a combination series parallel. But after we know that, then we will utilize, if it's parallel, we're going to use these rules, and if it's series, we're going to use these rules, and the whole time, we're going to be coming back over here utilizing this. Okay, so let's break down the series rules first. The voltage total in the circuit, total voltage is equal to the load of voltage 1 plus the load of voltage 2 plus the load of voltage 3, all added together is the total voltage. And then the amperage in a series circuit is going to stay the same. So let's draw a series circuit, simple series circuit, and look at what we're talking about. If we know that this is a 120 volts circuit, and we have a circuit with 3 bulbs in series, do we recognize that we have 3 bulbs in series? We do, so we're utilizing these rules over here. If these have resistance values that are different. Let's say the resistance value is 4, 5, and 6 ohms. We can use these rules to come up with the rest of the possible situations. So we know that the voltage across this bulb is, so E1 is going to be plus the voltage, if I took my voltmeter right there, the voltage of bulb 2 plus the voltage of bulb 3. Okay? It will be the total sum of 3. And we know that if we add those up, what's it going to equal in this particular circuit? It's going to equal 120 volts. Okay? Now, we also, this is an easy rule with series, is that in a series circuit, we can take our amp clamp and we can clamp it around any part of that circuit and it will have the same amperage at any point. Here, 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 or here. The amperage remains the same in a series circuit. Okay? So now, rules of a parallel circuit, let's look at those. First of all, we have to recognize if we're dealing with a parallel circuit. We've wired many of them in lab, and we can look at this circuit right here and see that we have 3 loads parallel to each other. Okay? Now, the rules that go with the parallel circuit state this. First and foremost, that you can go to the voltage of any one of those bulbs, and if we know our total voltage in the circuit, 120 volts, that we could take our voltmeter and we could come to each bulb right across each load, and we know that the voltage is going to remain the same all the way through a parallel circuit. That's why we use parallel circuits much more in wiring than we do series circuits, because we want loads to stay the same on voltage. Okay? Another thing that we know is that, using these rules, is that the amperage, the total amperage, now look at this circuit. Where could we take our amp clamp and get the total amperage? Right there. This wire or this wire would be the I amperage total. Why? Because all of the BB movement is going through this wire or this wire, feeding all 3. So, amperage of load 1 plus amperage of load 2 plus amperage of load 3 is going to equal the total amperage going to those 3 loads. That's total BB movement, right? All the BBs coming down through here, or vice versa, coming down through here, all the BB movement feeding these 3 loads have to come to this wire or that wire. So that's I total. Then, how would I get the individualized load current? I would have to get on the wire feeding that particular load. Okay, so this would be I1, I2, and I3. Okay? And I've saved probably the scariest part of the formula to last. We call it the funky formula. It's also called the reciprocating formula. And it states that the total resistance, now that's the dent in the pipe using redneck theory, but the total resistance, so if this had a resistance of 2, this had a resistance of 3, and this had a resistance of 4, states that the total resistance will always be less than the least of these 3. So the total resistance would be less than 2. And why is that? Because we're using the reciprocating formula. Now, I will individually in lab talk to you about how to use your scientific calculator to use this, or to do this, okay? To perform this task, you're going to have to find your button that says x minus 1 or 1 over x button. You will have to utilize this button on your calculator to be able to perform that particular formula. Okay, so we've wired a lot of series circuits, we've wired a lot of parallel circuits in our lab already. So a lot of this is identifying what we're dealing with. Okay, so let's look at an example of utilizing Ohm's law, either series rules, parallel rules, and we will always be using the Ohm's law to analyze a particular circuit. All right, so for instance, we have a circuit that looks like this right here. We have a circuit with 3 loads, and we have to look at the way that they're wired to be able to establish if they are series or they're parallel. And we can see that this bulb and this bulb and this bulb share the same path. And whenever a circuit shares the same path, we automatically know it's a series circuit. Now, I try to make this as easy as possible. And I work real well with graphs. So to perform any Ohm's law problem, the first thing I want to do is I want to build me a graph. And what are we looking for? We are looking for voltage, amperage, and resistance of loads 1, 2, 3, and the total. Okay, that's what we're after. We want to find the voltage, amperage, and resistance of load 1, of load 2, and load 3. And we want to find the total voltage, the total amperage, and the total resistance. Now listen carefully. You will always have some information. Automatically take the information that you know and put it in the graph. So the very first step, identify what kind of circuit we're dealing with, series or parallel. We've done that. It's a series. Second thing that we're going to do, build us a graph. EIR, the number of loads, and total. Third thing that we're going to do, take our knowns and pop in the box. So we know that load number 1 has a resistance of 3. We know that load number 2 has a resistance of 4, and load number 3 has a resistance of 5. And we know that we have a total voltage of 12. Okay? Now, is there anything on step number 4, is there anything that we can do instantly by looking at our rules of a series circuit, because we do have a series circuit? Is there anything that we can do right off the bat? We know that our resistance, the total resistance, is the sum of all of the resistance added together. Now it just so happens here that bulb 1 has a resistance of 3, bulb 2 is 4, and 3, 5. So we know the individual resistance of each load. So if we take 3 and 4, that's 7, and another 5, that is 12, we know that we have a total resistance in this circuit of 12. How do we know that? We use rules of a series circuit and know that resistance adds up to total. Now, do we know 2 of the 3 categories or the properties of electricity? Do we know the total voltage and the total resistance in this circuit? We do, so we can come to our Ohm's law and plug in our total voltage, which is 12, and our total resistance, which is 12. And 12 divided by 12 is 1. So, E divided by R, 12 divided by 12 is 1. Now, we've established that our amperage, our total amperage in this circuit is 1. What do we know about amperage in a series circuit? Amperage stays the same. So the amperage through all loads would be 1. Now, do we know two properties of each one of the loads now? We do. So we can take I times R of each load. What we're doing is multiplying here using Ohm's law, E over I times R, to solve for the third property. Okay. Let's perform one parallel, and then we will call that video good. I am going to go ahead and get out my calculator here because I will need that for a parallel formula using the funky formula. Okay, so I got that out. And I want to put a problem in here that I know I can solve. Sometimes if you just try to freestyle one, you won't have the correct values. So let's look at this circuit right here. A lot of our circuits that we look at won't just be black and white series or traditional straight line. So we have a load here, we have a load here, and we have a load here. Okay? And this has 480 volts. This load, R1, resistor 1, is 60. Resistor 2 is 30, and resistor 3 is 20. Okay, so step number 1. What was step number 1? Identify, is it a series circuit or is it parallel? Each one of these loads has its own individual path coming to it. 3 individual paths. So we can recognize that it is a parallel circuit. So everything that we will be doing on this circuit comes from the parallel side. The second thing that we do after establishing, is it series or parallel? Second thing that we do is we're going to build us a grid. And what are we looking for? E, I, or R. 1, 2, 3, and total. We've got 3 loads and we want to know the total. So step 1, we know it's a parallel circuit. Step 2, we built us a graph. And then the next thing we do is write in what we know, okay? Our givens. So we know our total voltage. Total voltage is 480 volts. Resistance number 1 is 60. Resistance number 2 is 30. Resistance number 3 is 20. That's all we know about this circuit. Now, because we are given resistor 1, 2, and 3, and we know it's a parallel circuit, we could come over and know that to find our total resistance, we could plug it into the funky formula and come up with total resistance. Now, unless you are much, much more of a math whiz than what I am, you're going to have to utilize your calculator for this. Now, if you want to go ahead and get your calculator out now on this video, I'm going to give you time to do that. and you're going to be looking for a button on your calculator that will look like x minus 1 or 1 minus x. Mine, it just so happens, I have to hit function, and it is a 1 over x. Okay? Now for mine, each time that I want to put in a value, I have to hit function to be able to do it. So the first thing that we're going to do using this formula is we're going to do what's in parentheses first, and that's the bottom. And so we know load 1 is 60. So I'm going to type in 60, second function, 1 over x, plus 30, second function, 1 over x, plus 20, second function, 1 over x. It's very important right here to hit equals. A lot of students forget to do that. So I have added up my reciprocals all the way to that, and then the very last thing I do is hit 1 over x again. Now, the answer that's on your calculator at that point should be less than the least. They call this the less or the least formula, or less than the least formula. So the answer of this is 10. Is that less than 20? Yes, it is. So we're going to use it. Okay? Once again, to punch that in my calculator, here's what I would put in. In any order, 61 over x plus 31 over x plus 21 over x equals, and then hit 1 over x again. Or if you have x minus 1, you're going to go 60. X minus 1 plus 30x minus 1 plus 20x minus 1 equals, and then once again hit that button. So what is our total resistance? 10. Okay, now what do we do? We can utilize, we know 2 of the 3. We can go over to Ohm's law, and we know the total voltage is 480, and we know our total resistance is 10. If we take 480 divided by 10, I do believe that is 48. Does everybody agree? Okay, now, something else that we could have done, and this nearly happens on every Ohm's law problem, there's different orders that we could have done. Probably you already seen it by utilizing this, that what does the total amperage, or I'm sorry, the total voltage, what does it do? The total voltage stays the same. So 480, 480, 480. Now actually I would have known 2 of the 3 of all 3 loads, so I could have went 480 divided by 60, put that in, 480 divided by 60, 480 divided by 60, or I'm sorry, 480 divided by 30, 480 divided by 20, put those values in here, and then I could have added them up, and it should equal 48. So I'm going to go to my calculator here and punch in 480 divided by 60 equals 8. That's 30's half of that, so I guess that's going to be 4. And 480 divided by 20, 24. That ain't right. That's not right. 480 divided by 30 equals 16. Okay, so now I should be able to use the parallel rules. Amperage adds 8 plus 16 plus 24, and it should equal 48. Okay, the next video segment that I'm going to do will be combination series parallel circuits. We have to be able to work individual series and parallel problems before we can do combination series parallel problems. In your packet that you had to buy for this class, also on Canvas, first thing you need to do after this class today or sometime today, go in the computer lab. You get 250 free pages to print off. That's using our paper. Go in the computer lab, pull up Canvas, and print off every homework assignment today. So you'll have this weekend and you're going to have next weekend to do these. Also, next week you'll be getting more familiar with Ohm's law, and I will be adding some combination series parallel circuits.